Hi everyone, this is Winnie from Delta Electronic. I'm located in Taiwan, so right now it's 3:30 a.m. very early. I'm happy to introduce with Delta, we developed the algorithm and the program to help engineer to have more efficiency and more accuracy for the pre-emphasis when we are dealing with the circuits for NRZ or PAM4. So what happened in the real channel? The first, you can see the original is the waveform. If it is the ideal waveform, is like a square wave. But when the speed going up and up, the loss, you can see in the top here, the loss is linear increase when the signal's frequency is increased. So there's introduced a lot of the loss. So you can see after the channel, the channel transmit to from the transmit to the receiving side. The red color, red waveform is the original waveform, but go to the receiving side is like the blue color one. So if here is a VIH and the VIL, then you never can recognize which one is high, which one is low. This will cause the signal, the high-speed signal from the transmit to the receiving side, the data is distortion dramatically. So so there is a we call pre-emphasis or de-emphasis, whatever. There's we need to do something. So please go to next page. So how to improve the signal quality? The loss is there. We cannot change because that's nature, that's intrinsic there. So we cannot do anything, but we can do something. For example, here is we call when the waveform is become not ideal. Even it's not ideal, but we can do a little bit, do some the convolution to get the ray one in the second photo. You can see the amplitude is lower, but at least we can exactly recognize which bit is 0, which bit is 1. So this is from the time domain. But if we go to see the frequency domain, is the button drawing. You can see the blue one is the original frequency response. But what we do is we add the function as the ray one. So when in the low frequency, we will depress the amplitude. But when we go to the high frequency, we will increase the energy for the signal to let in the receiving side, we can easy to understand it's 1 or 0. Okay, so we can go next. So I think everyone know when we do the NRZ or PAM4, we very care about the eye. So if the first one is we don't do any emphasis, then the waveform is distortion a lot. Compared to the eye diagram, if we convert to the eye diagram, you can see the eye is very small. It did not open. It did not open. You will let the when we have the transceiver, he cannot recognize which one is what is 1, which one is 0. But if we add the emphasis, is in the bottom one. So you can see the amplitude is smaller, but you can see the eye is very clear. This is what emphasis is doing. Even the we reduce some amplitude. The total amplitude is smaller, but for the laser side, it can easy to understand which one is high, which one is low, so it can convert the signal to the next step correctly. Okay, so okay, thank you. We move next page. In the traditional, most of we need to fine tune the parameter. In the traditional, we need to have the engineer to set the emphasis and do the management, record all the waveform and calculate the result and do the cycling many times. Then we find today one of the parameter, the emphasis to do the rest of the management. This will take a lot of time. So, okay, we see next page. So here is if we do it by management, so the engineer need to fetch the data. We need to set the emphasis and do the management like this one, and calculate all the result and do the rest measurement. This will take a lot of time, the huge time. It is around 2 weeks to 3 weeks. But when we complete all the tests, then the report, nothing, because the engineer need to take another 2 weeks to summarize all the data and create a report. It will take another longer time. So that's why we are thinking, is any way we can do better to have the engineer have more time to do other things, not be trapped on this management and do not just do loop. Since it's a do loop, something is do loop, then we think maybe we can do it automatically. So, okay, next page. So we are thinking if we can do the automatic, then yeah, we can save a lot of time. So from here, the flowchart, first we were based on our SI simulation. Then we will select some of the emphasis. Then we will run the algorithm to do some we can call auto scan for some emphasis. Then we will do the management. Based on this cycling will about 10 to 15, then we will choose of the emphasis, the best one in of the emphasis. Then we will do the automatic management. This way, for example, we do the comparison here. So if we do the menu and the current our automation to find the good emphasis for this this switch, automatically each lane will take around 15 minutes. For the menu, the first lane it will 120 minutes, but the second one, the rest maybe just 10 minutes. But the 10 minutes is just find something we can use, but it's not the best. Maybe not so good for the switch. But and also do the management because it's a menu, so each lane will take 20 minutes, and the engineer need to stay there. They cannot go anywhere. But for the automatic, even each lane it will take 15 minutes, but the engineer don't need to stay in the lab, because each port, for example, NRZ, we have the 4 lane, so it will take at least 1 hour and 1 hour for the scan. So the engineer can do other things. He don't need to be trapped on the station. And also the most different is the report. When we complete the management, the report is there. So we don't need to do additional job to create a report. So the total time from the scan to the remanagement to the test report, the automation will save half the time compared to the manual. Okay, so I will do the detailed introduction. So next page. Yeah, so we develop the program, the GUI here. This is the GUI here. So you can, engineer can choose the emphasis value, and all the information is also here. Then you just click run it. Then here we will see the flag here. Then he will do the running the automatic to run the management and record all the data in the right side here. So all the waveform, no matter I diagram or anything, he will record here and store in the data. Okay, next page. So once we complete each lane, we complete the management, the program will create the test report automatically. So he can do the summary, each report, each lane, it's pass or fail. And also the emphasis data, you also can create at the same time when we complete the management. And the next page. And also we talk about the eye diagram. For the eye, we are very care about the eye height, eye width. So you also automatically create the table for the eye height, eye width is the same. And also we can, since it's a program, we will create the Excel file. So we can do some analysis, because each lane, each pole is different. So we can see maybe something different in the different pole or different lane. So we have the example on the next page. Yeah, for example, the first diagram is the insertion loss. We do the simulation is in the blue line, and the red one is what we measure in our real switch. So you can see if this here have the difference, huge difference, then we need to go back to our SI simulation to see what's going on. And the second drawing is we can see record all the lane for the eye height and eye width to see is in the switch is the eye height, eye width is consistent. And the third one graph, you can see the first one is when we can disable the TS, then we can check is the noise in each lane is any abnormal situation, so we can take a look into. And the other one, the blue one, is the AC common voltage. We set the emphasis to change the waveform. So we will see if we do this kind of if the emphasis will cause any common noise abnormal. Abnormal, that means it did not, it's changed a lot. It did not consistent with other lane. This is what we are doing. Okay, next page. Here is my summary. Is so the equalization are using in all the circuits to do the to recover the signal because of the channel loss. So we develop the automatic program and the algorithm to help engineer to speed up the management, and also the management data, the emphasis is more accurate, and all the measurement and is more efficient. So you can see when we do this kind of management automatic. You can save half of the time, and also to avoid the menu mistake. So this is an NRZ example here. We are doing the PAM4 right now, and so far so good. So, but the present time is here. If the end of this month, I believe we will have the complete result can share to everyone. So I think, okay, next page. I think here is my last page. So we are not sure if anyone have any suggestion or any comment for our development. And I'm part of our engineer to do this kind of the creative idea, and we implement. But I'm not sure if anyone have any comment or suggestion. I think this is my last page. Thank you.
Winnie, first of all, thank you for coming in at so early to present this. Yeah, sorry about that. If we have known you are from Taiwan, we probably scheduled at the earliest slot. We thought you are from the Bay Area, Delta Electronics. Apologize for that. The first thing.
That's fine.
The second one, I have a question. So, is there any dependency of hardware, whether it's a NIC or switch, that your automation firmware can run on?
Say again. You mean
is there any dependency on the hardware, like whether you need to use a specific switch or a specific NIC that your automation firmware can run on, or it's generic and it can run on anything?
Yeah, it's a generic. It's a generic because if the SerDes is actually it can use in all the similar how to say, all the, even the PCIe we also can use that. But if the SerDes have some emphasis we can tune, then we can use this method. We can use using this algorithm. Yes.
Okay, so there are some configuration file that we need to set, and then to use this tool.
Yeah.
Okay.
Yeah.
Okay, that's how you match. Got it.
Mm-hmm.
Yeah, it's really interesting. Where can we get this automation software and the user guide for this?
Oh, maybe we are not planned to open to everyone yet. So maybe I can discuss internally if we can share to OCP or anyone. Yeah, but if anyone is interested, I think you can send me the mail. We can discuss.
Yeah, I think it seems interesting to me. However, this is not an area that my group do, but I have a sister group that work on a similar thing. So the thought is like, yeah, to connect both parties to get this.
Yeah, we have this kind of the activities. The engineer really spend a lot of the week to find a good parameter for emphasis. So we are thinking is maybe have something we can do better. Yeah, maybe we can discuss after the meeting. Yes.
Yeah, and I encourage you to share this with the team. Yeah, the intent to share it, the presentation in open session like this is to intend to share it. Yeah, at a later stage when it's ready.
Okay. Okay, thank you.